Number 12 on formative A. I'm going to start by distributing the 5 on the left side of the equation. 5 times x is 5x. 5 times negative 5 is minus 25 equals 5x plus 3. If you think about these as each expression is a line, then the 5x minus 25 has a slope of 5 and a y-intercept of negative 25. The other side has a slope of 5 and a y-intercept of 3, which means they have the same slope, but different y-intercepts, so the lines will be parallel, and they will not intersect. This means we'll have no solution. Some students are going to recognize that right away, that because the x values are the same, but the constant values are different, we'll have no solution. If you don't recognize that, though, you can just keep going like normal. So maybe the next step that you do is add 25 to both sides. It's a good step. It gets rid of the 25 on the left by giving you that 0. You did a nice inverse operation. On the left side, I'll have 5x equals 5x plus 28. Again, you can pause and think that if I have 5 times x on both sides of the equation, if I add 28 to one of those 5x's and nothing is added to the other 5x, then there's going to be no solution. There's no number that's going to make sense of that. If you don't recognize that, that's okay, because you can still just keep going like normal by subtracting 5x on both sides of the equation. 5x minus 5x is 0. On the right side of the equation, 5x minus 5x is still 0, and I have a plus 28. So now I have a 0 equals 28. 0 does not equal 28. That doesn't make sense. Since that's a false statement, we say there's no solution. That means that there is no number that x could be that would make these equations be equal to each other. If I looked at it on a graph and I gave myself an expression for each one, the 5x minus 25 might be something like this, and the 5x plus 3 might be something like this. The lines are going at the same slope or the same rates, so they are not going to touch ever, which is why there is no solution, because there is no intersection point.